Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, our topic is as a part of ground improvement techniques, what we understand based on the different soil types, based on the soil conditions, we are going to consider choose the what type of adaptable technique for give the better results for that particular scenario. So, as a part of that, here we are understanding this one more airport conditions which are in Japan, located in Japan. So that particular case study of this international airport which is located in Japan. So today we are understanding about this. So before understanding about this Kansai International Airport, Osaka, that is Japan, it is one of the most remarkable example of the large scale ground improvement projects. So till now, what we understand from these ground improvement techniques as a part of their soil conditions, according to the depend upon the type of soil, what kind of procedure we are following for getting the best technique which we are going to choose, all these parameters including these ground improvement projects. So here in this particular case studies, they refer to techniques used to enhance the properties of the soil to meet the specific engineering requirements. We have different types of engineering requirements: stability, stability point of view, and settlement, water content, moisture content, strength. Most when coming to the soil, the important one is the soil bearing capacity. These are all the parameters they are going to include in this particular requirements. Such may increase load bearing capacity. Some of the situations they require a reduced settlement. It depends upon the what type of soil it is, what kind of construction we are going to do. These are the parameters that plays a crucial role for understanding the ground improvement techniques. So here we are choose the techniques for enhancing the properties, for decide what we required for the construction of that project. So that is the main motto under that. The complete parameters are involved in that particular things. So according to that, we are going to enhance all these specific engineering requirements such as engineering, load bearing capacity, and also reduced settlements. Here, it's very important of these often employed when your natural soil conditions are inadequate or construction, especially in areas prone to the instability, mostly in coastal regions, soft clay or reclaimed lands. These are all there. So soft clays, silty clays. So these kind of soft clays, all they require different kind of properties for the construction what they have naturally. For all this, we have choose technique which are desired the required properties of the soil. Like this, we are understanding this ground improvement technique uses to enhance the properties of soil to meet the specific engineering requirements such as engineering load bearing capacity or reduced settlement. In this objective about this particular case study, the Kansai International Airport, which is located in Japan. So what kind of ground techniques are there? We will understand using this project overview. This location, it is in Japan. What kind of geographical conditions are there? We have understand those geographical conditions. So in this Kansai International Airport, it is located in Osaka Bay and approximately 5 kilometers offshore to that particular location, the main island of the Japan. So it is built on, it is a man-made island. It is not a natural one. It is a man-made island. How they, on which basis they are, how it is man-made, what is the requirement for preparing this land, island. So it is the island, and what is the reason behind this, and what kind of properties are involved, what kind of nature of the land it is. These are all involved. It is man-made. And one more important parameter what we understand from this is, so it is man-made. So that's why the properties and what are the elements are involved in this particular man-made island is known, and it is recordable. So all the data it is there. So which spans around 4,000 meters along and 2,000 meters wide. And we know what kind of soil conditions are there, how we built up this man-made island. What kind of various parameters, environmental conditions are there involved in this, we may understand in this overall project overview. Coming to the environmental conditions, the site is seismically active zone, because we know this is seismically active zone, and the location in a bay area posed challenges due to the exposure to typhoons, tsunamis, and fluctuating sea levels. These kind of environmental conditions and environmental observations we are going to understand in this overall project overview. So based on the location, first we are going to understand the geographical settings and what kind of environmental conditions are there, and how we are going to build this airport, and what kind of capacity, what we are expecting from this airport. According to that, how we are going to build, according to the various design considerations, how we are going to understand. These are all the parameters which we are going to understand in our design consideration. In this project needed that significance, this airport demand in 90s, 80s, what is the need and significance of the project for better understanding about the geographical scenarios and also the social status of that particular locality, and what kind of demand is there in that particular locality. So how we are going to understand the requirements of that particular locality, and how we are understanding the scenarios. So in this 1980s, increasing air traffic in this particular region, including cities like Kyoto and Kobe, created the new need for this airport. The existing Okaso International Airport was struggling with congestion, noise pollution, and expansion limitations. So, in future also, we are going to understand all these parameters for constructing the same kind of environmental in that particular locality is also plays a role. So, here what we understand. So, based also the expansion limitations is also there because of this air traffic. We are going to, this is the one of the need and significance of the particular project. So here selection of the island site to avoid issues of the noise and minimize and lack of acquisition problems, a decision was made to build the airport offshore and reclaimed land. So because of that, these are the reasons for to avoid the issues of noise and to minimize the location and the acquisition problems. A decision was made to build the area offshore or on reclaimed land. So for this, once this is the project overview where we are going to construct as per the social issues, also as per the government policies, decisions, and the people's aspiration. These are all the parameters they are going to choose the selection of the land site. Not only for the engineering characteristics point of view, engineering, what kind of give these kind of easiness to the construction and further maintenance and everything. So that was not only the parameter, that is also the parameter, that not only the major parameter where we are going to select the landslide site for the construction of any construction work. It depends upon the various parameters, not only our technical terms, not only purely technical terms are not, they are involved, but at the same time we have to understand the local emotions, and we have to understand the local environmental conditions, and how it is helpful for future generations. These are all the various parameters are involved. These kind, any kind of project, those are which are used for public utility. Whenever we are using, whenever the area in the world, wherever it may be, whenever it may be, it depends upon the such kind of parameters also. So the selection of lands, the site, it is not 100% from the technical issues, not only from the technical parameters. Of course, it is there, but even though we have to understand under various sentiments and emotions of that particular locality also involved. Not only for this particular case study, any kind of project, not only for airport, dams, bridges, road constructions, railway zones, railway bridges, railway platforms, extensions, and where the ring road is going to go, the choose of the land where we are going to construct with public demand is more whenever it is required. So we have to follow the regulations as well as the law. We have to obey the law and all these parameters. Which one is best? We have to choose. As a civil engineers, we have to face all these kind of challenges. So the selection of site, it's there. It depends upon the various parameters. So once we choose the challenges, what we are facing in this particular construction, challenges what we are going to. So in man-made island on soft clay, so on the one of the greatest engineering challenges was the soft clay, and that's compressible clay, and which is unsuitable for supporting large structures. So these kind of environment, it is not suitable for heavy structures. But as per the various parameters involved for choosing this site, we have to select that particular area for this airport. It's not only for the not only for the planes. It has some of runways and terminals, so much of volume and so much of the population and so much of traffic is there, human traffic and air traffic. We have to balance all these parameters. Different kind of environmental is required for that. We have to understand those kind of airport runways and also the terminals we have to consider. So these kind of type of structures are not suitable, but even though we have to construct there only, that is the one of the major challenge in any kind of construction. In reclaimed land, the island was created by digging soil from the seabed and surrounding areas, but the natural marine clay layers underneath were not ideal for this bearing heavy loads. So whatever we are going to construct for an island purpose, it is okay for that purpose. But whenever we are constructing airport, means the heavy loads, again it is going to the under these clay layers extension. So that is not acceptable. So it is not for ideal for these bearing heavy loads. These clay layers extended to significant depths and exhibit pure engineering properties. So here we are talking about these kind of pure engineering properties. Those are compressibility. So based on these soft and they are not suitable for heavy structures. So we are going to exhibit pure engineering properties such as high compressibility. These are all the challenges which we are going to face in this construction work. High compressibility, low shear strength, and high water content. High water content. So in this high compressibility, marine clays tend to compress significantly under load. In low shear strength, soft clays have low resistance to deformation, making them prone to the settlement and instability. High water content, water saturated soils tend to consolidate slowly when subjected to load, causing prolonged settlement. These are the various engineering properties which are involved in this kind of challenges which are we are choosing the according to the place. Now, here what we understand in this particular project overview, consolidation settlement is the key problem. So in this consolidation, so it is nothing but the process by which soil gradually reduces in volume over time due to the explanation of water from its pore spaces when subjected to a load. This is nothing but the consolidation. Consolidation, it's not at a point, it is a process. Consolidation, it is a process by which soil gradually reduces in volume over the time, not at a time, not like that it is going to reduce its volume over the time due to the explanation of water from its pore spaces when subjected to a load. So in a marine clay, this can take years or even decades. Now, soft marine clay behavior. So here what is that is there? That is nothing but the soft marine clay here. Soft marine clay. So here that soft marine clay behaves, the island posed a serious risk for long-term and uneven settlement, which could be cause of damage to the infrastructure, disrupt airport operations, create long-term structural instability. We are going to understand various types, that is equal to instability and damage infrastructure. These are all involved in this particular consideration. Now, in this cause damage to the infrastructure, uneven or differential settlement could damage the runways, taxiways, and buildings by creating cracks or misalignments. In disrupt airport operations, settling could lead to operational downtime for repairs, affecting both safety and efficiency of the airport. So, create long-term structural instability. Continued settlement over time would require constant maintenance and could reduce the lifespan of the facilities. This is the key problem what we understand from this particular challenges. What we understand, this is the key term which we are understand. From this, we are going to choose the which type of technique give the better results for getting all these challenges what we understand from our previous level. This high compressibility, low shear strength, high water content. So which kind of technique is suitable? Now in this settlement predictions, initial projections, slow settlement process, long-term monitoring. So here this initial projections, engineering predicted that without intervention, the island would experience excessive settlement 10 to 12 meters over several decades, especially during the initial years of the post-construction. And so, slow settlement process, the soft marine clay consolidated slowly, meaning that settlement would occur both during and long after construction. This posed a challenge to both initial construction activities and the long-term operational stability of the airport. In long-term monitoring, there was a concern that the island surface would continue sinking after the airport opened, particularly under the load of the airport infrastructure, such as runway, terminal building, and parked aircraft. Here, these are the predictions what we understand from these initial projections. Slow settlement process and long-term monitoring. Long-term monitoring. So there was a concern. So here, for based on this all these settlement predictions. So here this settlement 1 to 12 meters over several decades, especially this post construction and also the slow settlement process consolidated slowly would occur both during and long term construction whenever this long terminal stability of the airport and the long term monitoring. So there was a concern that Iceland's surface would continue sinking after the airport opened, particularly under the load of the airport infrastructure such as the runways, terminal buildings, and parked aircraft. And now, what are the various other problems which are linked with these settlement? That is earthquake risk. Because of this region, it is a soft clay and also the water saturated clay. Had a high potential for liquefaction during an earthquake. Liquefaction occurs when saturated soils lose their strength and behave like liquid, which could lead to these kind of various kind of failures of these airport structures. In these and also the tsunami and different types of typhoon protection gives these airports location in this, especially in these Japan areas. We may frequently observe these kind of tsunamis and everything, and also had to the consider potential settlement. So this kind of potential settlement when planning protects measure against the tsunami and other are happened from the sea. Any additional settlement would affect the height and effectiveness of the sea walls and other protective structures. These are the other problems which are linked up these things. In this design criteria and goals, they are going to what kind of design criteria it is. They are going to reduce the settlement and also the accelerated this consolidation is one of the major parameter. We have to understand this consolidation and also the long term stability. The stability is also the parameter. These are the focused parameters which we are going to understand in these our design criteria and their goals. Minimizing differential settlement. The goal was to ensure uniform settlement across the entire island to prevent damage due to the differential movement of the structures. In accelerating consolidation, the challenge was not just reducing the amount of settlement but speeding up consolidation process so that the bulk of the settlement occurred before major construction, limiting post construction settlement. In ensuring the long-term stability, techniques had to employed to enhance the soil's strength and ensures long-term stability in the face of potential earthquakes and also the various typhoons and future loading conditions from airport operations. These are all the parameters which are involved in this design criteria and the goals. Coming to the ground conditions. So first we have to understand these ground conditions. The ground condition at this particular locality. So what we understand, it is a soft marine clay, soft clay. So first we understand the soil profile. So the ground conditions at this particular Kansai International Airport site were one of the most critical factors in the design and construction process, as they involved challenging soil characteristics that required significant ground improvement techniques. In soft marine clay, depth and thickness. The site was located on an alluvial plain at the bottom of this bay, where the natural seabed consisted of a thick layer of soft, water saturated marine clay. This clay layer extended up to a depth of 20 meters, varying across the site. So the upper layers were typically weaker, within the lower layers are also presenting compressibility challenges. Because of this, we are facing this compressibility challenges. And one more and few are there, that is high water content. So the soft clay in the area had very high water content with a water content ratio. The weight of water compared to the dry weight of the soil. Water content ratio is nothing but the weight of water compared to the dry weight of the soil, reaching as much as 80 to 90%. This meant that a significant portion of the soil's volume was made up of water, making it highly compressible when subjected to loading. So we have to understand highly compressible when subjected to loading. In low permeability, marine clay low permeability, meaning that water drains slowly from the soil. This creates a challenge because the soil settles slowly as water is expelled from its pore of over time, making the settlement process lengthy. In this low shear strength, shear strength refers to the soil's ability to resist deformation under stress, which is the key property for supporting loads like buildings or runways. The soft marine clay in the area had very low strength, meaning it deformed easily when subjected to external loads. When it comes to these external loads, it is going to deform because of this low shear strength property. And bearing capacity, the natural soil lacked sufficient bearing capacity to support the heavy loads from the airport's infrastructure, such as runways, taxiways, and terminal buildings. Without improvement, the soil would not be able to support the weight of the airport structures. So, without experience, significant deformation or collapse. In plasticity, the marine clay in this region exhibited high plasticity, meaning it could undergo large deformations under load. This makes it prone to creep or long-term settlement, where the soil continues to settle even after construction is complete. Now, high compressibility. In this compressibility, marine is typically highly compressible, meaning that it tends to shrink or compact under load. This compressibility of the soil is critical factor when constructing on soft ground, as excessive comparison can lead to uneven settlement of structures. In settlement potential, without any ground improvement, it was estimated that the soil At this particular where we consider this locality of this site could experience settlement in the range of several matters, especially during the initial construction and loading phases. This settlement would have been differential, meaning different parameters of island would settle unevenly, potentially causing damage to the airport's infrastructure. As a part of long consolidation time, due to high compressibility and low permeability, the soft marine clay would take many years to fully consolidate and settle under the weight of the airport structures, which would cause long-term issues. So like that, we are going to understand the each property, in that what kind of various parameters are involved, how they affect, how we are going to overcome using the fine technique used for getting these are into the for construction is possible. So in underlying layers, so deep clay layers, in that upper soft clay, there was deeper layers of similarity compressible clay that extended further below. These deep layers, to less compressible, were still problematic. Some layers consist of silt and fine sand with poor drainage characteristics, further complicating the settlement predictions. In liquefiable soil, in addition to the compressible clay, some layers contain sand which could be susceptible to liquefaction during seismic events, particularly in the event of an earthquake. Liquefaction occurs when saturated sand loses strength and stiffness due to the earthquake shaking, turning the solid ground into a fluid-like state. This phenomenon could have catastrophic consequences, leading to the collapse of infrastructure and loss of support under the railways or terminal buildings. In initial conditions and problems without ground improvement, this excessive settlement. So if the project had proceeded without ground improvement, it was anticipated that the settlement under the airport's heavy infrastructure like runways, taxiways, terminal buildings could reach several meters over time, given the soft and high compressible nature of the marine clay. Settlement in some areas could have exceeded 10 meters. In differential settlement, one of the major concerns with this site was the uneven or differential settlement across the island. Different parts of the island were expected to settle at different rates depending on the thickness of the clay layer and the intensity of the load, and also the intensity of the loading. This could result in cracks, tilting, or misalignment in critical infrastructure such as runways, causing operational and safety issues. In slow consolidation, this time factor and infrastructural damage. So in this, due to the low permeability and high water content of the clay, settlement would have occurred over long period. The process of consolidation could take decades if no ground improvement techniques were used. This would create problems for the airport during and after construction, as infrastructure would continue to settle after the airport opened, requiring ongoing maintenance and repairs. So in infrastructure damage, prolonged settlement could lead to differential settlement within these structures, leading to the crack in pavements, tilting in buildings, and uneven runway surfaces, making the airport unsafe for operation. In risk of liquefaction, seismic vulnerability in this particular located area in a region prone to earthquake without ground improvement to lose water saturated sand layers. The site could be liquefied during an earthquake. This would cause a sudden loss of strength in the soil potentiality, resulting in large scale ground failure and structural collapse. So, in impact of liquefaction could render the ground incapable of supporting heavy loads like aircraft or terminal buildings. The result would be subsidence, collapse of critical infrastructure, or significant operational disruptions during an earthquake. So, in this long term instability, creep and long term settlement, even after initial consolidation, the clay would continue to settle slowly under constant loads, particularly from heavy structures such as runways and terminals. This slow long term settlement, known as creep, would continue to cause problems for many years, those who are, if not controlled. So, the maintenance cost, long term settlement would require frequent and expansive maintenance to correct runway surfaces, building foundations, and other critical infrastructure, significantly increasing the cost of operating the airport. So, these are all the summary of challenges. So, this excessive settlement up to 10 meters or more, long-term differential settlement leading to the infrastructure damage, seismic risk due to the liquefaction during earthquakes, slow consolidation process making construction and operations risky, increase in maintenance cost, and ongoing instability issues. These are the challenges what we understand from these kind. Now, what kind of ground improvement techniques? So, based on the type of soil and construction, it leads to choose the technique. So here, sand drains and preloading. So the preloading, placing a temporary surcharge, this extra load on the ground surface to accelerate the consolidation of the soft soil, soft clay. In this sand drains, vertical sand columns installed into the ground to shorten the drainage path and accelerate consolidation. Water is squeezed out of the quickly from the soft clay, reducing the time required for the settlement. How we apply in this particular airport, more than 2 million vertical sand drains were installed with preloading applied for several years to ensure significant consolidation before construction. Stone columns. In this, vertical columns of compacted stone, gravel, or sand installed in these soft soils to increase the load bearing capacity and improve drainage. So, these sandstones, load bearing capacity and the improved drainage conditions are the parameters which are helpful in this particular ground improvement technique which we choose. So it works, improve the stiffness in terms of properties point of view. We are going to understand about these. That is nothing but the stiffness and also reducing the strength, reducing the settlement, and so increasing the soil strength. So here, depending upon these kind of stone columns ground improvement techniques, it is going to increase the load bearing capacity and improve drainage It works, improves the soil stiffness and allow water to escape, reducing settlement and increasing soil strength. So coming to this particular case study, stone columns were used in areas where the sand drines were less effective, particularly under heavy load zones like runways and terminal buildings. Now, deep cement mixing, DCM. In this, it involves mixing cement or lime into the ground to increase strength and reduce compressibility. This specialized equipment is used to mix cement with in situ soils to form columns of improved material stabilizing of the soft clay. Coming to these particular applications, these deep cement mixing was used in the conjunction with other techniques to stabilize specific areas of the island, especially under critical infrastructures like the runway and aprons. Move on to the other ground improvement technique, that is dynamic compaction. It involves dropping heavy weights repeatedly onto the ground surface to compact loose or soft soils. It works, this compaction helps to densify the soil, increasing its load bearing capacity. It is going to apply used on the reclaimed land to densify the upper layers of fill material and improve stability. In these kind of different ground improvement techniques we choose in this particular case study. In this, these are the results we are going to observe, and also monitoring is required. So in initial settlement during the pre-loading stage, that significant settlement up to 6 meters were observed, which was controlled by the ground improvement technique. As per the long-term performance, the ground improvement measures successfully reduced post-construction settlements to manageable levels. Continuous monitoring of the island settlement has been conducted, and while some settlement has occurred since construction, it has remained with tolerable limits, that is 1 to 2 meters over the last 20 years. In impact of infrastructures, the runways, terminal buildings and other facilities have remained operational without major issues related to the differential settlement. In overall this conclusion, these ground improvement techniques plays a crucial role in this particular construction of the airport, allowing for successful development of infrastructure and various challenges on these soft soils. So the combination of preloading, sand drines, stone columns, deep cement mixing and dynamic compaction provide a comprehensive solution that minimizes the settlement and also analyze the soil stability. This case study highlights the importance of the selecting the right mix of techniques for given project and role of monitoring, ensuring the long-term success. This particular case study we understand like this, and we will see in our next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.